Welcome to week 9. This week you'll be doing a couple of different things. You'll start the week by doing some practice tests for the upcoming PARCC test, and you'll be taking that test whether you're a full-time student with us or a part-time student. If you're a part-time student, you'll be taking that at a different location, so I'll talk more about that in a separate video that I will make specifically about that beginning of the week. However, later in the week, you'll be learning about quadratic functions, and you'll be learning some vocabulary terms and how to solve some problems relative to quadratic functions. So this video is meant to cover those kinds of things. So this comes from the first folder that you'll be working in, which is 5.2, and you'll notice that they ask you to use a graphing calculator. So I'll be doing the task here with you on a graphing calculator, so that you can see that. I don't know how many of you have a graphing calculator, so if you do, you're welcome to do this on your own on that graphing calculator. If you don't, I'm going to try to provide you with several options where you can get an online graphing calculator, and then also later in the video I will show you a website that you can use to help you graph things on the computer. So for now, I'll just be using my online graphing calculator, and if you choose to download one that I send in a link, this is pretty much what you'll be working with as well. So they ask you to enter the function, and so to do that, we go to the y equals screen right here, and you type in there. Notice there's already something there, and it's not what I want to have there, so I will clear that, and then I will type in x squared minus 2x minus 8. So I type in x squared, and then minus 2x, and then minus 8. And then it asks me, so I've done step number 1, it asks me to press the second and then the graph button, and notice above the graph there's the word table, which is what it shows here, and you're going to view a table of values. So, or we are going to view a table of values. And they're asking us, use the arrow keys to scroll up and down for which x values does y equal 0. So this gives me the x and the y values that make this equation true. So if I plug in an x value of 0, 0 squared minus 2 times 0 minus 8 gives me negative 8. So this gives me a list of x values that are being plugged in and y values that are coming out using this equation, and they want me to look for values where the y is equal to 0. I see one here, and that x value is 4. I'm going to use the down arrow key to see if I find any more. Well, they seem to be getting bigger for the y values, so maybe I'll go back up the table and see if I can find any others. So there's the one at 4. Oh, and there's another one at negative 2. And actually they're both on the screen, which is really nice. So notice that the y value is equal to 0 two times in this scenario, one at x value of 4 and one at an x value of negative 2. If I continue to work up the table, notice that these numbers will just keep getting bigger and bigger going that way. So it looks like these are the only two values that will give me a 0. I'm going to get them back in the window here. It asks me to press graph to graph the function, and then look at at which points does the graph intersect the x-axis. So I hit graph, and here is my parabola, and notice that this is the x-axis, and the parabola hits the x-axis at negative 2 and at 4. And those are the same values that I found as x values in the table that gave me a y value of 0. So the x values that I plug in that give me a y value of 0 show up on the graph as x-intercepts right here. Now it asks you to graph the function x squared minus x plus 3. So I'll go back here and do that. I'm actually going to just modify what I have here a little bit. And then it asks me to view the table and see for which values I get a y value of 0. Let's see here. It looks like I don't get any zeros. That's interesting. Okay, let's see what else is happening here, what they're asking me to do. They asked me to view a graph of the function and determine where the graph intersects the x-axis. If I hit graph, Well, my table didn't give me any y values of 0, and my graph kind of confirms that by showing that this graph, this parabola, does not have any x-intercepts, or values where the parabola crosses the x-axis. So based on this, you should be able to do the discuss and describe questions on your own. So I'll let you do those. But I just wanted to walk you through kind of how to do that on the graphing calculator. So here they ask you, I don't know that they use this terminology in this case, but you'll be learning about something called zeros. And so it's important to know what the zeros of a function are. So I've posed the question, what are the zeros of a function? And why do we need to find the zeros? And what I'm going to do is, see if I can do this really quickly here. So notice I made the word zeros red, and also in Y, I made the letter Y red as well. And the reason is that the zeros of a function are the places where the Y values are equal to 0. So that's what you're looking for when you're asked to find the zeros. So you are asked, if you're asked to find the zeros, and I may have misspelled that, I don't know if there's an E there that comes before. I think there might be. I may have misspelled that. But when you're asked to find the zeros of a function, you are asked to find the x values that give you a y value of 0, much like what we just did in the table. So that's kind of what I tried to do here in the red, is just kind of give you a catchy way to remember that you're looking for where the y is equal to 0, and that's what I have right here. So here is an example that you are going to have actually from your homework assignment, and they are asking you, now, well, actually let's take a look at the graph really quickly, and then we'll take a look at the question they're asking you. So on the graph, notice that the zeros are at -2 and at 4. Actually, this is the same graph that we just looked at, coincidentally, that we just looked at on this example here. But let's say that it wasn't. I want to show you how you could answer this question. But the zeros are at -2 and at 4. They ask you which function has the zeros shown in the graph. Now, you could do a couple of things here. You could graph this on a graphing calculator and see which equation has the zeros given. But I know not all of you have a graphing calculator, and if you are asked to do this on some kind of a park test, as we have a test coming up here soon for the state, you might not have access to a graphing calculator, so I wanted to show you a different way to do this. So if the zeros are at -2 here and at 4, those are the x values. So x equals -2 and x equals 4, where our y value is 0. Remember, that's what we said in the last slide, that that's what a 0 is. An x value that makes a y value 0. On the graph, that means that it sits right on the x-axis. So what I could do is I could take each of these equations, so like let's say I'm going to take A, and I could plug in -2 and I could plug in 4 to see if I get a y value of 0. I'm going to plug in 4 first because it's positive and I kind of like that. So what I'm going to do is this. I'm going to hope that this gives me, so I'm going to put a question mark, a y value of 0 when I plug in 4. So 4 squared, because 4 is being plugged in for x, plus 2 times 4, plus 8. And does that give me 0? Oh, that definitely doesn't give me 0. Now, I could plug in -2, but since 4 doesn't work, that would be really a waste of time because this one is clearly not going to be the answer. So then I would want to do that for B, for C, and for D, and I would need to check and make sure that both worked. So if 4 does in fact work, that's not enough to know that you have the right equation. You'd have to plug in -2 as well. But if 4 doesn't work, then it doesn't matter if negative 2 works because they both have to work. So if 4 doesn't work, I can cross that off and not have to try the negative 2 to eliminate it as a possibility. So the idea is that you would plug in the zeros that you see on the graph into the equation to see, do they really give you a y value of 0? And only one equation of the 3 remaining will actually work out. This does not actually equal 0, by the way. Another vocabulary term that you're going to learn about is the axis of symmetry for a parabola. And so this is just a quick review of the idea of symmetry. And I think we've actually looked at a picture like this maybe before in this class. So this is an example where a line has been drawn down the middle, and it's kind of like a mirror reflection line, and they call it actually a mirror line, where what's on one half of the line is an identical reflection to what's on the other half of the line. And so we're going to be looking at that with parabolas as well. So here are some parabolas. You're asked to do a couple of things, and the first time I looked at this, it was a little bit unclear to me what I was being asked to do. I had to kind of think about it for a few moments, and so I just wanted to model for you how to complete what they're asking you for here. So first of all, I want to come here. Remember that when we have a quadratic equation, I'm going to put a y here actually, that we have some number times x squared, and we call this number being multiplied by x squared the a value. And we have some number times x, we call this number being multiplied by x, the b value, and then we have a constant, and we call that the c value. So coming back here, they've given us the equation 1x squared. Well, 1 will be the a value. I'm kind of trying to go off to the side here. Minus 2x, remember this is like plus, sorry, it's very small typing there, plus negative 2. So really our b value is negative 2. And our c value, remember this is like plus negative 3, our c value is negative 3. So they give you two other examples here. The a value would be negative 2, the b value would be negative 8, the c value would be negative 6 for this problem. So you'd need to identify the a, the b, and the c value, remembering to look for those negatives. Here they ask you to identify what is a is 1, what is b is negative 2, so they've done that for us. Then they ask you to put b over a as a fraction. So b is negative 2. And if I divide that by a is 1, that division gives me negative 2. That gives me that 1 goes into negative 2 this many times. So I can actually simplify that. Some of these may not be able, actually they should all be able to be simplified as I look at them. Then down here they ask you for the axis of symmetry. So let's talk about that a little bit. Remember, the axis of symmetry is that fold line or the mirror line where one half of the parabola is a reflection of the other half of the parabola. Now, the axis of symmetry in these cases is an x equals line. And notice again I've highlighted the x in red. So it's an x equals line. In this case here, this dashed line is at an x value of 1. And notice that every point on the line has an x coordinate of 1. So this equation for the axis of symmetry is the line x equals 1, which is why they've written this here. In this example, let's see, the line is a vertical line, which is an x equal line. That's again why I've highlighted the x here. And in this case, though, it's not x equals 1, it's x equals negative 2, because that's where all of the x values would fall. So you're going to write the axis of symmetry as well as filling in the rest of those blanks. And you're also going to learn about, I think we talked about a vertex in the first section. So the vertex is either the lowest point of the parabola or the highest point of the parabola. And you'll notice that the axis of symmetry always passes through the vertex. So here's the vertex of this parabola, and the axis of symmetry passes right through it. Here's the vertex of this one, it passes through, vertex of that one, it passes through. So the axis of symmetry will always pass through the vertex of a parabola, and that will be something that you'll be learning about a little bit later on. So you can find an axis of symmetry from a graph by looking at it. You're also going to learn a couple of other strategies to find the axis of symmetry. One of those will actually use the zeros from a graph, and so you'll identify that. I think one of them will use the vertex, and then there's another way that uses the equation for a quadratic. So actually, let me do this. Let me pause. Okay, so I am going to write the equation for a parabola, or a quadratic equation. That gives me the graph that is a parabola, x squared plus 2x plus 8. And when you're asked to find the axis of symmetry from the equation, and again, that's just one of the strategies that you'll be learning, you use the a value, which in this case is 1, and the b value, which in this case is 2. You don't actually end up using the c value. So here's how you find the axis of symmetry from an equation when you don't have the graph. Remember, it's an x equals line. That's why I highlighted the x here in red. It's an x equals line when it's that up and down, and I think in all of our cases we'll be dealing with an x equals line for an up and down parabola. What you do is you put the opposite of the b value over the a value, and you'll notice that you've done that already in this table over here. But then you take half of it to find the axis of symmetry, and taking half of it basically means that you put a 2 down here with the a. So in this case, let's plug in. My my b value is 2, so I put a negative 2, and then down here I'm going to put 2 times, my a value is 1. That's not a very good 1, but it's supposed to be a 1. This gives me negative 2 over 2. My x-axis, my axis of symmetry is the equation x equals negative 1, and that is an equation for a vertical line that would go through negative 1 on the graph, and that will be the axis of symmetry. In this case, they're going to ask you which of the following functions has a graph with an axis of symmetry of x equals negative 1/2. What you'll need to do is you will need to get the y by itself, first of all. So notice in this equation, for example, the y is not by itself. So you'll need to get the y by itself. If I was going to do this for equation h, I would subtract 2x squared from both sides, and that would give me negative 2x squared plus 2x plus 5. So if I subtract 2x squared from both sides, this is what I get. If I were to use what I just said about the b value, which is 2, making that opposite, and putting it over 2 times the a value, this gives me negative 2 over negative 4. Well, that reduces to positive, because a negative divided by a negative is positive, positive 1/2, and I want it to be negative 1/2. So this does not give me the correct axis of symmetry. Oops, but you would need to do a similar thing for these other problems. Get the y value by itself, here it is already by itself, and then use the equation that we just talked about to find the axis of symmetry. Couple of quick things. I'm going to run out of time here. I can tell this is going pretty, I'm running out of memory on this video. So this is a problem where you're asked to use the graph of the height of a water bottle over a certain amount of time after it's been launched, and you're supposed to answer some questions. So I did have some problems with some kids doing things like this on an assignment where you're asked what it represents, and instead of telling me what it represents, kids will tell me what it is. It's the number 2, or it's the number 4, whatever. You're asked to tell me what it represents. So in this case, let's skip that one. When it asks you what the zeros represent, let's look at that one. The zeros are the points where the graph crosses the x-axis, and they seem to be at 0 and at 8. So if we look at the information that we have here, this seems to be time, and this seems to be height. Notice that the 0 and the 8 are time values, and I think they're measured in seconds. 0 seconds and 8 seconds. Notice that at that point, the height is 0. So it is 0 feet high. But it's not just enough to tell me what those numbers are. You need to tell me what they represent. So this represents that at 0 seconds, the water bottle, is on the ground. It's 0 feet high. And this represents then that it, travels up into the air, and then again at 8 seconds, it hits the ground again. So this represents when it was launched from the ground, and then it hits 8 seconds and it's back on the ground. And so when you're asked what it represents, you need to tell relative to the the problem given to you here, what they represent. Last thing is a quick graph of quadratic functions here. So you're going to be doing a little bit of an investigation about y-intercepts. And so recall that a y-intercept is the y-coordinate of a point where a graph intersects the y-axis. You're asked to use a graphing calculator to explore the y-intercepts of some quadratic functions, and I'm going to give you an alternative that I'm going to pause and go to this website, and then I'll move on from there. So this website is, I don't know how to say this exactly, Desmos.com, and you hit that red launch calculator button that I did, and then you can type the equations in here. I forgot what our equation was. Let me go check real quick. X squared minus 2x plus 3. So if we do x, and we can use that caret key that we've used before. So if we do x, and then when I used the caret key, it automatically made it an exponent, but they actually have them down here as well, you'll notice. So x squared minus 2x plus 3, if I hit enter, actually I don't even have to hit enter. I can, and it'll go to another line here, but it graphs that parabola for me, and I'm looking for the y-intercept. And in this case, the y-intercept is 3. Notice that the scale here seems to be that each mark is half of a unit. So this whole distance here is 1, and that's 1. So this y-intercept seems to be 3. You can use this website to graph the rest of the equations that are found here, and then answer the questions that they're asking you. So I'll make this available to you as well.